Physics 2 Magnet Lab. So my table of contents, so what's in is this introduction. Then we're going to go over the physics principles in it, and then, the experiment and code, and then finally the discussion questions. So just a quick introduction and then the principles. So the purpose of this lab is to measure the magnetic field of the bar magnet and observe the distance dependence of that magnetic field. So some key physics principles we're going to be using is the Beyonce law, where you can kind of find magnetic field at any distance, and then also our magnetic field dipole rules. So to set up this experiment, we have our magnet that was given to us along with our ruler tape. And so we'll set that ruler tape up to the parallel of the magnetic field. And then I use my phone with the magnetometer app to kind of record the magnetic field at different locations and distances from the magnet. So here are kind of our results and our data. Here you can see the trend we saw here was as the distance increased from the magnet, the magnetic field decreased. And you can kind of see that with my graph. It has a slope of negative 2.2126, y-intercept of negative 13.48, and then here you can see it when it's off axis, so it's not that perfect parallel, and you can see here the magnetic adjustment for Dunedin, and we got our B net was 0.0001, and then our calculation, so how to get our dipole moment. So we know that it's equal to 2 the end slope times r cubed, because that's our parallel, or our dipole B parallel, and it's also equal to k times r to the n. And so you can set those two things equal, and we know what our k is. From our graph, we know what our slope is, and so from there you can calculate what our dipole moment is, and I got it was 6.96 Newton meters per Tesla. And so then we can use that to put this into a GlowScript code. As you can see here we have my function for a magnetic field to create a magnetic field, and that's kind of where we do use our Beyonce law, and that's kind of used to make the function with the magnetic field, and we make arrows. And so this is kind of my results from running my GlowScript code. And so now for some discussion questions. What if we haven't oriented our experiment to compensate for magnetic north and instead laid our meter stick at some indeterminate angle? The magnetic field would still be the same. The magnetic field at that distance wouldn't be different, because that is the magnetic field and magnet, but our values that we record would be different because of the different angle, and so it'd be a little bit harder to manipulate it into the information we need and get our kind of magnet and get our magnetic moment. What if we stuck two identical magnets together and ran the experiment again? What would that change? Well, the magnetic field would increase because the magnet's kind of like a dipole, and if you increased it, then the magnetic field would also increase. Thank you.